Hello everyone! In today's video we are going to take the first look at Gmsh, a three-dimensional finite element mesh generator. Generally it is like a NetGen, but NetGen uses another license. NetGen employs LGPL license while Gmsh employs GPL license. Like we saw in previous video, building process of mesher together with Open CASCADE technology is full of shadow points, and in this video we are going to review and fix them. The first step towards our demo is Open CASCADE technology building. If you are using Visual Studio, there is nothing to do, but if you are using MinGV, Open CASCADE technology sources should be patched. Technically, you should go to standard_error handler class and you should enable standard export macro in the following methods: in register callback, in unregister callback, in destructor, and in constructor. Typically, these methods, they have default implementations on Windows, but when you emulate Linux environment, you can see that they are not defined. So if not defined, we have these inline methods. Nevertheless, I have already patched Open CASCADE technology in frames of 32810 issue, and currently it's not a problem. The second step for us is Gmsh sources patching. We have to do it like we did it for Open CASCADE technology. This time we don't need to dive into the source code itself. The only thing we need to update is CMake lists for Gmsh. So technically Gmsh has two flags. The first one is enable OCC and enable OCC CAF. CAF stands for application framework of Open CASCADE. Technically, each flag adds some Open CASCADE technology libraries into Gmsh to link against them, and this machinery is done within a method called findLibrary. This method, it uses some hints to look for libraries like here, here, and here. So my modification was to add more hints for Visual Studio, because originally we have here only VC8 and maybe VC9. Currently, starting with Visual Studio 2015, VC14, it stands for Visual Studio 2015 and upper. The next thing to update is related to OCC convert signals. We remember that something was wrong with them, and similarly Gmsh sets some flags after setting libraries, and my version looks this way. So if we use Win32 and it is not Visual Studio, only in this case we add OCC convert signals macro. Once again, I patched the sources of Gmsh to simplify your life. So if you are using the modern Gmsh, this work is done. The third step for us is building of patched Gmsh sources. For this purpose, I have already prepared the folder with the source code, with binaries, and we can go for the standard procedure. Let's do it for Visual Studio 2019. At this stage, CMake looks and checks for available options and types. When processing is finished, we can go to ungrouped entries and disable build testing. And the most important and the most interesting group for us is called enable. And for simplicity, we can disable everything in this group. And after that, we can enable options of interest. We want to enable dynamic, shared. I'm not sure, maybe it is necessary to enable only one of them. We want to enable eigen. We need to enable mesh, because without it we cannot mesh our data. And we want to enable two Open Cascade options. You should enable Open Cascade TBB if you build with it. At the first glance, everything is okay, but actually we haven't passed any information related to Open Cascade location. So we need to add a new variable called CMake prefix path, and it should point to our installation of Open Cascade. Let's use not the latest release, but 7.5 is fine, I guess. Configure, and Open Cascade is found. Great. After that, we can press generate and open project. And after that, we can build Gmsh. The last step for us is building our demo application. For this purpose, I prepared our dependencies. I built Gmsh, and I built Open Cascade Technology, and also I prepared a demo application containing some necessary includes. And I want to remind you how to include a third party in a Visual Studio environment. First of all, we need to go to C++, go to General node, and includes can be added using additional include directories node. Libraries can be added using additional library directories. So here you see that we add the folder with Gmsh and the folder with Open Cascade Technology. And also we need to add the libraries of interest. Here I don't distinguish between necessary libraries of Open Cascade Technology and unnecessary libraries of Open Cascade Technology, just for simplicity. And in this demo application, we need to think of our interface. Let's convert brep, its native text or binary format of Open Cascade Technology, to STL. So it means that our input, if argc doesn't equal to 3, means that it is unexpected number of arguments. So return 0, and it is std cout unexpected number of arguments. The first step, it is loading of our shape. Stop this shape brep tools read. So we want to read in this shape from argv from 1 and pass brep builder instance. Okay, now we have a shape and we should pass it to Gmsh. For that purpose, we need to initialize Gmsh stuff. Gmsh initialize. After that, we can use Gmsh routines. So the first one is related to shape loading. Import shape's native pointer, so we need to convert it to void pointer. We should create some vector pair object, Gmsh vector pair, I don't know, some output parameter, and let's keep the last parameter to be true. After that, we need to synchronize the model with data we loaded from OCC. Synchronize, great. And after that, we need to pass some meshing options. Gmsh option, set number, and here we should pass some string. So I dig documentation of Gmsh, so the variable name is mesh size min. So let it be 0, and mesh size max, let it be 2. Of course, these two parameters can be adjusted by some heuristics. For example, one can use a fraction of the bounding box of the shape for it, but it is not the case for us because here I just demonstrate the logic. And for mesh generation, we should go to Gmsh model mesh generate, and this method accepts one parameter representing the dimension of mesh to generate. We want to get a surface mesh, so we want to write here 2. When meshing is complete, we need to write it to STL format. For simplicity, we can go to Gmsh write and pass here argv from 2. Launching of the code can be found in debugging session. You see that we pass 2 parameters. It's ball prep and mesh STL. We can build our code, and just to remind you that when you use release here, you need to copy all necessary dynamic link libraries to launch the code. Here it is. And we can see the result in MeshLab. That's it. I hope this guide was useful for you guys. See you next time.